So let's talk about fuels. Fuels are hydrocarbons. Okay, so they are the hydrocarbons or hydrocarbon derivatives. Okay, so petroleum gives all the aliphatic hydrocarbons. Okay, and the coal gives all the aromatic hydrocarbons. Okay, so we have two things. First is petroleum. So all the aliphatic hydrocarbons. What do you mean by aliphatic hydrocarbons? Means aliphatic hydrocarbons means straight chain, okay, a branch chain. This is a chain, not in a ring form or not in a cyclo form. It's just in chain. A simple hydrocarbons are aliphatic hydrocarbons. So all the aliphatic hydrocarbons are derived from petroleum. Okay, so all the aliphatic hydrocarbons are just extracted from petroleum products, and petroleum are already present in our nature. Okay, carbons. And coal, and the coal gives, which is also present in nature. Coal is actually the purest form of uh, allotrope of carbon, right? Amorphous allotrope of carbon is coal, and it gives aromatic hydrocarbons. Aroma is a benzene like structure. It's like aromatic hydrocarbons. This all the aromatic hydrocarbons are derived from coals, okay, which is already present in nature. So our organic compounds are especially hydrocarbons, especially what hydrocarbons are derived from petroleum and coal. Okay, so aliphatic are derived from petroleum and aromatic are derived from coal. Now, how these hydrocarbons are extracted from petroleum or coal? These all hydrocarbons are extracted from these things by fractional distillation. Okay, so through the process of fractional distillation, through the process of fractional distillation, aliphatic hydrocarbons or aromatic hydrocarbons, basically hydrocarbons are just obtained from their natural resources. Okay, so hydrocarbon is it's a big picture. Fractional distillation is a big picture. You know what is distillation? Distillation is just a process in which it is certain amount of temperature, it is heated, and the product are just collected. Okay, so it is in fractional form, means the temperature difference should not be much, so that we can easily collect the I'll show you picture. Okay, I'll show you picture. Let me show you picture. Fractional distillation of hydrocarbons. Okay, so fractional distillation. See, look at this. This is a very good picture. Okay, wait a second. You can see here, this is what is a fractional distillation of crude oil, which is already present in nature. Okay, let me just go back, screenshot it. How do I screenshot it? Okay, now I'll just edit it from here. Okay, so as you can see, it's all chamber. It's a chamber where there are different temperature zones in each compartments of this chamber. Okay, so you can see here. Okay, there are different temperature zones. So 50 degrees Celsius, see, here is different temperature zone. If the temperature increases, the product is turns into gaseous form, first into liquid form or vapor forms. This changes, and from each, according to the temperature, whichever the liquid has been formed, it is either liquid or gases. They are either collected from these things. So this is what is fractional distillation. Fractional means it is if a compound has a, if two compounds or two or more compounds which have a similar boiling point or melting points can be separated, is what is fractional distillation. Distillation is simply boiling or something kind of. So carbon C5 means carbon 5 means there are 5 carbons in a compound. So if the 5 to 10 carbons, so such products are called petrol. Okay, so this is we are refining, or so we are actually distilling the crude oil. Okay, so naphtha is what is carbon 8 to carbon 14, and carbon 10 to carbon 16 is kerosene, and carbon 14 to carbon 20 is diesel oil, and carbon 20 to 50, here is all details. You don't need to remember. I'm just giving the idea that hydrocarbons, these are hydrocarbons, right? So these hydrocarbons are extracted by fractional distillation. So this is what is the basic idea about fractional distillation, and how the fuels are extracted, or how the petrols or diesel, whatever we need, okay, whatever we need, how these are extracted. So this is what is the gives the basic idea of fractional distillation. Okay, now after obtaining fuel, okay, we obtain fuel now. We obtain hydrocarbons, right? So this fuel's quality is determined by some certain terms. And what are those terms? So those terms are actually the quality of gasolines. I'll give the heading of quality of hydrocarbons. So the quality of hydrocarbons, we have to just read the two basic things. Okay, so one is octane number. Okay, so I'm writing the subheading of octane number, and another one is C10 number. The main difference is it is a number which gives the quality of hydrocarbons, right? But octane number is what is used to find the quality of petrols. Okay, so this is concerned with petrols. So this is what is concerned with petrols. But C10 number is concerned with diesels. Okay, I don't know what the spelling, but I guess this is correct. So if we compare the octane number and C10 number, octane number seems more important. Okay, so this one is what is more important than C10 number, because this is where the most questions are framed from this octane number. Okay, so the basic definition of octane number is it is the amount of isooctane. This is the amount of isooctane present in the mixture of isooctane and heptane, which gives same anti-knocking qualities as the fuel under consideration. So here are some few terms. Okay, so let me highlight some few terms which needs to be discussed. So there is isooctane here, there is anheptane, there is anti-knocking agents. So octane number is just simply the amount of isooctane which is present in a mixture of isooctane and anheptane. So what is isooctane? So it is a molecule. It is just a molecule. Okay, so let me talk about isooctane. If you just know the structure of isooctane, it is like this. Okay, it is like this. Isooctane is simply CS3 CS3. It's just a molecule. You don't need to remember. I am just describing. CS3. So this is what is isooctane. IUPAC name is its IUPAC name is 2,2,4 trimethyl pentane. So the octane number of this compound, which is isooctane, is 100. So this octane number is 100. So the octane number of the isooctane is the octane number of isooctane is 100. The octane number of isooctane is 100. And let's talk about anheptane. Anheptane is simply a heptane molecule. Okay, it's a simple straight chain hydrocarbon, which is heptane of seven carbons. Okay, so if I just have to draw the structure, it is like anheptane. It's simply CS3 CS2 CS6, 7 carbon atoms. So 1 2 3 4 5 6 7. So this is what is anheptane, and the octane number is of anheptane is found to be 0. So now right, why we're comparing the compounds isooctane and n-heptane. Why are we comparing the compounds isooctane and n-heptane? Because it is found that the octane number of isooctane is what is 100, and n-heptane's octane number is naturally it's 0. So we just by definition, and the octane number is defined by definition. Octane number is defined as the amount of isooctane which is present in the mixture of this n-octane, sorry, isooctane and n-heptane. So this is what is the definition of octane number. So now the octane number increases in the order. So which compound? So every compound, every fuel has certain kind of octane number, right? So how do this octane number vary from compound to compound? So let us discuss that thing. So the octane number, I'm just writing some orders, okay? So the octane number follows the order. First is the straight chain hydrocarbon has the lowest octane number. So wherever you see the straight chain hydrocarbon, you see the lowest octane number. Straight chain hydrocarbon. Straight chain hydrocarbons has the lowest octane number, and that is 0. Look at here, this is also a straight chain hydrocarbon, isn't it? So n-heptane is a straight chain hydrocarbon which is found to be 0. So straight chain has the least number of octane number, and above the straight chain hydrocarbon there are branched chain. So this is branched. See, this is also branched chain hydrocarbon, isn't it? This is a branched chain hydrocarbon. So it's more than 100. So there are also compounds which have the octane number more than 100 as well. Branched chain hydrocarbon. So there is a branch chain. There are also olefins. Do you know olefins and alkenes? What is olefins? Olefins are alkenes, okay? So olefins is also cycloalkanes, then cycloalkanes. Cycloalkane means the closed ring of a carbons, okay? So the closed ring of the cyclic rings of a carbon are what is cycloalkanes. Alkanes, the closed cyclic rings of alkanes are cycloalkanes, simple definition. And the compounds which have the most amount of octane number is aromatic hydrocarbons, which is it can be more than 100 as well. Aromatic hydrocarbons are like 100, 50, 60, 70, more than 100 are what is aromatic hydrocarbons. So this is important. So this is where the questions are framed from. So you have to remember this order. So wherever in question one molecule is given, and you just, if you know the molecule, which is the molecule, either it is straight chain or olefin or it is aromatic hydrocarbons, you can easily predict which has got the octane number, okay? So this is what it is. So let me give you a small question based on this. If you can solve it, then you are done with this octane number, okay? So let me give you a question. So the question says which of the following has the most greatest, right? Let's say greatest, GREATEST, the greatest octane number. So option number here goes hexane. Option number B, we've got isooctane. Option number C, we've got phenol. No, let's not say benzene. Okay, so benzene. And option number D, we've got 2,2-dimethyl propane. Now take the correct answer. What do you think? Which has got the greatest octane number? So what could be the answer? It's absolutely yes, it's benzene. Okay, so look at this. Hexane has got the least amount of octane number. So we have also, by definition of octane number, there is one compound which is hexane, which is practically its octane number is 0. So this is hexane is what is an octane number is 0. So it has got the least amount. Also, it is a straight chain hydrocarbon. If you compare the straight chain hydrocarbon with branch chain or olefins or like that, the straight chain hydrocarbons have the least number, that is octane number. Okay, so least number of octane property, the octane number. So then isooctane. So isooctane has got, we also described in the definition of octane number, we know the octane number of isooctane, that is 2,2,4 dimethyl pentane. So this molecule is what is isooctane, and we have found this octane number is 100, right? And but it in the order, in the priority list, the isooctane comes in branch chain hydrocarbons, right? So benzene is what is aromatic hydrocarbon, and aromatic hydrocarbons are the greatest octane number. So to come out to dimethyl, also a branch chain hydrocarbon. So by knowing which molecule is what compound, either it is cycloalkanes or olefin, you can easily know the octane number dedicated to that thing. Okay, so here is also another term. Now let's talk about anti-knocking properties. So what is anti-knocking properties? Knocking is what is knocking. Knocking is a sound. The very defective sound that produced by the engine. So that is what is knocking sound, but here it is anti-knocking sound, which prevents such kind of knocking sound. It is what is anti-knocking agents. So it is one of the method. Okay, so anti-knocking agents. So anti-knocking agents, it is one of the methods of improving the quality of gasoline is to increase its octane number by adding some certain compounds which reduce knocking. Okay, so hear me properly. The quality of gasoline. Okay, so octane number is a number which which defines, which gets the quality of fuel, that's especially petrol, right? So this is what is octane number. So but how can we increase this octane number of the petrols or hydrocarbons, right? So this is what is there is where is the anti-knocking agents come into the role. Okay, so anti-knocking agents is what is they basically increase the quality of fuel, right? Anti-knocking, it decreases the knocking property, so that's why it is anti-knocking. And what does it do? It increases more the quality of fuel. So for example, there is a fuel which contains let's say isooctane, okay, which octane number is 100. How do we increase this octane number more? We have to add some anti-knocking agents. So that's where the anti-knocking agents come into fold. So the very very important example of one anti-knocking agent is what is tetraethyl lead. Tetraethyl lead is very important. So anti-knocking agent is what is, there are many anti-knocking agents, but we have to know some knocking agents. So one very much famous example is tetraethyl lead. So C2H5 is ethyl. Tetra means there are 4 ethyls, and lead is what is. So this is what is tetraethyl lead. This increases the quality of fuel. This increases octane number. Tetraethyl lead. Okay, but here's the problem. Gasoline treated with tetraethyl lead is known as ethyl gasoline, okay, or leaded gasoline. So this also in short form, this is known as TIL, okay, tetraethyl lead. So but it is, the problem is, this fuel is found to be very harmful gas, which produces harmful gas in the atmosphere. Okay, this found to be very pollutant. It is found to be one of the pollutant. So that's why it is what is stopped using nowadays. It is stopped using. So tetraethyl lead has been stopped as it creates pollution problems. Okay, so it is what. So nowadays the tetraethyl lead is not used as an anti-knocking agent. So this is what is anti-knocking agent. So we are done with this octane number. Now let's go to cetane number. Same thing, everything is same. Okay, everything is same. The only difference is in octane number the petrol comes into the role, whereas in cetane number the diesel come into role. In petrols or octane number there was isooctane, but here we have to know two terms, and that is what is hexadecane or cetane. One is cetane. In octane, what comes into the role? Which have the highest or 100 octane number, that is isooctane, right? Isooctane has the octane number of 100, and here the cetane has the octane number 100, and that is also known as hexadecane. Hexadecane is what is basically cetane. Hexadecane is basically cetane. Okay, so its structure is CH3, CH2, 14, and CH3. So this is what hexadecane. Hexadecane means there are, hexa means 10, decane means No, hexa means 6, deca means 6. So taken means take, and deca means 10, hexa means 16. So total 16 carbon. So 14, 15, and 16. So 16 carbons is what is 16 carbon compound. A simple hydrocarbon, which is cetane, is what is, you know, cetane. Yeah, hexadecane, also known as hexadecane, IUPAC name. And likewise, in octane number, n-heptane was one heptane was considered uh, octane number of n sorry octane number of n-heptane was considered as 0. Likewise, in cetane number, here comes the role of alpha methyl naphthalene. Okay, so which gives the cetane number of 0. So you don't need to know much details about cetane number like octane number, but you have to know some basic things about the cetane number, and this is what is I'm writing here. And this is what is alpha methyl, this is what is alpha methyl naphthalene. So this is alpha methyl, you know, in alpha position of the carbon, this is alpha position, right, of bonded carbon. So this is bonded carbon and this is alpha position, so that's why it's called alpha methyl, and this is methyl group. So alpha methyl naphthalene. So these two rings of benzene are what is, if these two rings of the benzene are combined, this is what we call naphthalene, and its octane number is found to be 0. Likewise, in n-heptane, whose octane number was found to be 0, here the cetane number, here the cetane number of this compound was found to be 0, and the cetane number of this compound, hexadecane, is found to be this is what is one of the things that needs to be remembered. Okay. There are also a few things I like to discuss here. Let's talk about some gases. Okay, so there are many kind of gases which are used in our household things. So the first one is LPG. So I would like to just discuss two gases which are very important, or might ask in the competitive exam, and that is, one is LPG and another one is CNG. So LPG, its full form is what is liquefied petroleum gas, and CNG is compressed natural gas. There are many hydrocarbons that forms these gases. Okay, compressed natural gas, this is natural gas. So whenever you see the term natural gas, uh, there is a mixture of, mainly there is in LPG, mainly there is a mixture of n-butane and isobutane, whereas in CNG there is also there is methane is the main compound, which are the highest. There are also other compounds as well. Okay, so there are many compounds which are present in LPG or CNG, but the main compound which constitute the most of the fuel is what is methane in compressed natural gas, and butane in what is LPG gas, liquefied petroleum gas. So here we finished our topic related to fuels, and we've done everything, and the questions are framed in each and every line. These questions are framed, these direct questions are there that might ask in the competitive examination. So good luck. Thank you so much.